I believe, for page 251, section 17.1. Now this is question 7 drawn out just to save time. It says the square is cut out from another square. So there's that little baby one. It's been cut out of this large one here. I still got a lovely fence in the background. I think it's lovely. Anyway, and I formed a shaded region. So I've shaded that green so it looks a bit like what's happening in the book. It says find a quadratic expression that represents the area of the shaded region. In other words, what is the green area there? What is the area of the big square, 2x times 2x, subtract from that the area of the little square, x minus 1 by x minus 1. So we do what it says on the tin. I better go back and work in yellows, it may not stand out. So work up here. So big square is going to be 2x times 2x, which is 4x squared. Dead easy. The area of the baby is going to be x minus 1 multiplied by x minus 1. So just break this open a little bit. I've got x squared minus an x minus another 1x, and minus 1 times minus 1 is plus 1. Okay, tidy it up a little bit. I've got x squared minus 2x plus 1, and that's the baby square. Alright, so that's the big one, that's the little one. And the area of the shaded part is going to be obviously the big bit minus that bit. So be very, 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 very careful working here. So it's 4x squared subtract this. Now watch what I'm doing. I'm doing this for a reason. 4x minus x, sorry, 4x squared minus x squared is 3x squared. Now minus 1 times minus 2x is plus 2x. That's why I put a bracket round it. Minus 1 times 1 is minus 1. So that is the area of the shaded part in green, just there all around the edges. Alright? Now I've got to factorise it. So all that was A, and B is factorise that. Well, if I've got it right, it's going to be really easy to factorise. So 2 brackets, 3 times 3 makes 3, so x times x makes x squared. The only way to make 1 is 1 times 1. So no arguments there. Well, 3 times 1 will be 3, so I've got 3 x's there. That's got to be negative because minus 1 times x is minus 1x. So 3x minus 1x is 2x's, which is that. And minus 1 times 1 is minus 1. So I factorised it correctly. I'm very confident with that one. Not very difficult. That's it really. Just about a grade A, I'd say. Next one, a little bit more challenging, I guess. Right. Well, that's my version of the picture on page 252, question 8. I've got a rectangle. There it is. It's obviously not a square because 5x is different from 3x plus 1. And here I have a parallelogram. By the look of it, it's not a rhombus, I don't think. It's 3x plus 1 and with a height of x plus 1. That's the background. Now here's the question. A hole is cut in the piece of metal that has dimensions that by that, so yes. The hole is in the shape of a parallelogram, so that's a parallelogram, as shown in the diagram, and they're breaking the question up for us to be kind. First of all, and they could have just said find an expression for the shaded area. They haven't done that. They said first of all, part A, find an expression for the area of the rectangle. So that's part A. So here's the rectangle. Well, it's going to be 5x times 3x plus 1. So 5x multiplied by 3x plus 1. Don't leave it like that, otherwise you won't get your marks. Work it out. That is 15x squared, and 5x times 1, 5x. So we get a couple of marks for that. B. Find an expression for the area of the parallelogram. Well, that's going to be the base times the height. And please note the height is x plus 1, not the slanted height. No good. So it's going to be 3x plus 1 multiplied by x plus 1. Bust it open, so 3x squared. 3x times 1 is of course another 3x's. And 1 times x is yet another x. And 1 times 1 is 1. Tidy it up a little bit by simplifying. 3x plus x is 4x, and 1 is on its own. There's our other couple of marks there. Right, so we've got 4 marks so far. Find an expression for the shaded area. Well, that's C. In other words, subtract the area of the parallelogram from the area of the rectangle, so be very careful again. So I've got 15x squared plus 5x's, take away all of this. So it's worth putting a huge bracket around it and dealing with it one at a time. Alright, so I've got 15x squared plus 5x minus 1 times 3x squared minus 3x squared minus 1 times 4x minus 4x minus 1 times 1 minus 1. Okay, now we tidy this up. 15x squared minus 3x squared is 12x squared. 5x take away 4x is positive 1x, and the minus 1's dangling by itself. Right, then it says I've got to factorise it. It doesn't look very nice to me, I'm quite scared, but anyway, let's just get on with it anyway, and I think I'll do the punchline now up here. So I'm now going to factorise this. Let me just rewrite it. I've got 12x squared plus an x minus 1. So 2 brackets. Now, oh, horrible. How do you make 12? 4 and 3. Should we try it? Just try 4 and 3. 4x, 3x. How do you make 1? 1 times 1. Alright, I think we've got this actually. 4 times 1 will give me 4x's. Minus 1 times 3 will give me minus 3x's. 4x's minus 3x's, 1x. I think I've got it in 1. So if I make that positive, that's 4x's. Make that negative, take away 3x's, gives me 1x. And minus 1 times plus 1 is minus 1. I've nailed it in 1. I'm very happy. So there it is. 4x minus 1 by 3x plus 1. That is the area of the shaded region right there. I'm really happy with that. Now the next couple of questions are these challenging, thought-provoking, difficult, dodgy, problem-solving ones. They terrified me just a little bit, so I did them on paper first. I think I'll be able to do it without looking, but let's just do it anyway. Question 9 is so worth it. Very A star, I'd say. It says I've got x squared plus kx, great, another unknown, plus 32. I'm told that this factorises and gives me x plus a multiplied by x plus b. And it says find a and b are positive values, or positive integers, it says there. Show that there are 3 possible values of k. Alright, I'll see what I can do. Well, look, this is all trapped inside 2 brackets. If I multiply it out, at least it'll look a little bit like this quadratic equation, quadratic expression there. So here we go, multiplying out. I've got x squared plus bx plus an ax, alright, plus an a times b, well, that's ab. Well, at least it's broken, it's all broken apart. Now look very carefully. X squared matches that x squared. Different colour, definitely, blue. The kx matches the bx plus ax, alright? So that matches that. And of course, different colour again, the 32 matches the AB, alright? Because that's on the end, the AB is 32, and the AX plus BX is the KX. So I've got to start forming little equations here. So I'm going to work in blue first, so I'm going to play with the KX. So here we go. KX is equivalent to AX plus BX, just writing it around the right way because A comes before B. Now look, if I factorise it, I can take out the x from each of the 2 terms, and so KX equals x bracket A plus B. I can cancel my x's, and so I've got K is A plus B. Well, we're getting somewhere, aren't we? Make the K look like a K, not like a scribble. So K is A plus B. Can't go any further. If I can work out what A and B are, I can put substitutions for A and B and work out my value for K. Apparently there are 3 possible answers. Now look, working in black on this side. I've got AB is 32. Well, let's think of all the ways of making 32 with positive integers only. Well, I've got 1 times 32 is 32. That works. I've got 2 times 16 is 32. That works. 3 doesn't work. 4 does. 4 times 8 is 32, and that's your lot. So there's the 3 possible ways of making 32 with positive integers. So look, I can say my A is 1, my B is 32. So here I'm going to say K is going to be 1 plus 32, which is 33. Here I've got my A is 2 and my B is 16. Doesn't matter which way round it goes, honestly. So A is 2, B is 16. So K is going to be 2 plus 16, 18. And finally, my A is 4 and my B is 8. So K is going to be 4 plus 8. Final answer, 12. And there I've shown that I've got 3 possible values for K. And that's definitely off the scale A star. Not too complicated, you just have to compare what goes with what. X squared with X squared, can't do anything with it. KX with AX plus BX, that works. And AB at the end matches the 32 at the end there. So that's how you do it, and you've done something like this before, those of you who've done the A star back in Unit 2. And question 10 looked very terrifying, but it's so not terrifying because I sort of did it in a few steps really on this separate bit of paper, unless I threw it away. No, it's there, I did it in a step, nothing in it. It just looks terrifying. It says this, I work in the middle, it says that this has one of the this quadratic has a factor called 2y minus 1. It's got that in it. So I've now got to work backwards and find the value of n. Okay, but look, I know that if this is one of the factors, this has to be another factor. Alright, it's all blank at the moment, but eventually I need to work backwards and work out what n is. Now look, the way to get 2y squared is to have 2y times y. So I'm getting somewhere. So 2y times y is y squared. I've got you. Now I've got to end up with minus 7y somehow. So look, minus 1 times y will be minus 1y. I need to get another 6 y's from somewhere. The only way to get a 6 is to shove a 3 right on the end. Alright, so look at it carefully. Oops, my pen connected, sorry. Let's see what we've got. 2y times y, 2y squared. 2y times 3, it's got to be negative to make minus 6y. Alright, have you got that? And minus 1 times y is another negative y. So minus 6y. And another minus y makes minus 7y. So I've got you. And look what I've got here. Minus 1 times minus 3 is 3. Therefore, n is 3. Isn't that easy? Now, if you're not sure where I'm coming from, let me multiply it all out for you the long way. 2y times 2y, just work over here, 2y squared. So I've got you. 2y times minus 3 minus 6y. Minus 1 times y minus another y. And minus 1 times minus 3 is plus 3. Simplifying, look, there's your minus 7y's, and there's your plus 3 at the end. And look, just by matching it, 3 there matches the n in that position. Therefore, n equals 3. And that looked really scary to begin with, but it's so easy. And now that's your 4th video on 17.1. It's really time to stop. That's a lot done. Again, we're working at a very high level here, so I'm quite happy to do you plenty of videos to make sure you get loads of practice. And I'll see you again in 17.2 sometime in the future. I'm really tired now, so catch you later.